Hello everybody, you're very welcome to this episode of Object-Oriented Programming. In this episode we're going to continue on looking at the iterator pattern and specifically look at comprehensions, which are little quick ways of expressing iterations through containers of objects. So they're like regular expressions, they're just very short ways of doing quite complicated things, and we have three types. There's the list type, the set type, and the dictionary type. So we'll start off and look at a list comprehension, which again is just processing lists fast. When you see the word comprehension, that's all it means. It just means reading through the list quickly. So they're extremely common in Python programming, and indeed we've seen a few already, and I've put them in the code, and I've talked about them a little bit already, but haven't explicitly referred to them as list comprehensions. With Python, there's always a quicker way of doing stuff, and Python allows you to do it. I have a rough rule. Every time I put in a comprehension, I add about 3 lines of comments before it to explain what it does, because otherwise it may be difficult for the person who's reading your code after you've finished programming it to understand what you've done. So always future-proofing our code and always thinking ahead about what the next developer is going to experience. We like to comment comprehensions. So let's say we had a problem. We had a list of strings, and these strings are strings of numbers, and we want to convert them into actual numbers or integers. So we have a list with the string 234, the string 75, the string 331, the string 73, and the string 5, and we want to convert them into the numbers 234, 75, 331, 73, and 5. How would we do it? There's a million ways of doing it in Python. Probably the most obvious way would be to create a new list, process each element in the list, and just convert that using the int to convert it into an integer. So the code might look something like this. We have our string array, which has our values. Then we have our output, the new array, which is the array of numbers. And then we have a for loop, and we say for each element in the list, and we're going to call each element in the list num, for num in string array, so that means for each value in the list called num, and then add onto the output list the integer conversion of that number into an actual number as opposed to a string value. And that'll do it for us. If our input is the string, our output will be the integer array. But is that the fastest way of doing it? Well, probably not. If we look at the code there, we can reduce it down to 1 line by doing this. So in this version of it, we say create an output list, output 2, open square bracket, and then close square bracket, which means give me the start and the end. And in between the open and close square bracket, we have 2 things. We have what we're going to do to each element. What we're going to do to each element is convert it to an int, and then how we're going to do it, we're going to go visit each element in the list and call that element num. So the crucial thing to understand is with the list comprehension, the first thing you see is what you're going to do with each element, and then the second bit in this case is, are we going to visit all the elements or not? So in this case, we're visiting all the elements. We're saying for num in string array, that is for each element in the array, convert that into an integer type. So we can add other parameters onto a list comprehension, but always the first thing we see in a comprehension is how we're going to change the elements. And it gives us exactly the same answer with 4 times less code. It's also possibly slightly faster in terms of implementation because we're not explicitly calling the append method. That means the compilation is probably faster and the implementation might be quicker. Python is so efficient anyway that this mightn't be as much an issue as you think, but it's arguable that a list comprehension is a faster way of parsing lists or files or collections of objects. We can also include an if statement at the end of the comprehension. So in this case, what we've said is, again, we're converting all the elements into integers, and we're going for each value in the list. But in this case, what we're doing is we're checking if the length of the string is less than 3. So in our case, we have The string 234 is not less than 3, so that won't be converted. String 75 though is less than 3, so that will be. The string 331 is not less than 3, so that will not be converted. But the string 73 and the string 5 are less than, so they will be output. So you'll get an output array of numbers, but it's only the numbers that are less than 3 in length. That's an arbitrary enough example, but if you can put a condition, if I've got a big long list of things and I only want to select certain elements out of it, all I need to do is just say if and whatever the condition is, and then that's a really quick way of doing that selection. I'll repeat again though, it's always a good idea to put at least 2 or 3 lines of comments in front of your comprehension explaining what it does. And list comprehensions can be used on anything that is iterable. So for example, text files are stored essentially one line at a time. At the end of each line there's a special character called a carriage return. We use the /n to represent the carriage return. So if I open a file and I say next, it'll give me the first line. Then if I say next again, it'll give me the next line, the next line, the next line, and so on. So let's imagine we have a file called mydata.txt, and we've actually seen this file before last time when we were doing file management, and it's got 7 lines in it. We'll note that the first line starts with letter P, the next line starts with letter D, the next line starts with the letter C, the next line starts with S, and the last line starts with the letter E. So even though it's a continuous sentence in a sense, when the way the file is stored is one line at a time. So we can treat that exactly like a list, and we can use a list comprehension to process through the file the same way we would process through a list. So if we wanted to just select all the lines that start with the letter C and stick them in a list, this is all we need to do. Open the file, and then what did we say the first element of the list comprehension is again? That's what we do to the file. So what we do to the file is print out the line, but do a dot strip, which means just remove the special carriage return character at the end of the line. And if there's any funny control character at the start, it removes that as well. So essentially just print out the line. For each line in the file, if the line starts with C, then include that. So what are we going to get? Are we going to get a file with just the 2 lines that start with C? No, we're not going to get a file, we're going to get a list, because it's a list comprehension. So the list is open square bracket, and the line about code readability, and then the second line about concepts. And it's a list with 2 elements in it, which are long strings. So if we were searching a file for errors or warnings or messages, a log file, these typically system administrators run computer programs every night, and then in the morning they have to examine log files to check if any of the overnight jobs, any of the processes that run when everybody else is asleep, if anything happened to them. So using a list comprehension would be a very quick way of finding errors or warnings or things like that. That's list comprehensions. Now let's move on to set comprehensions. So we'll remember that a set in Python is like a list. The only difference is it doesn't allow duplicate values in it. So if I have a set that has 1, 2, 3, 4 in it, and I try to add the number 3 in, it'll allow you to add it in, but it'll just have 1 instance of 3 in it anyway, because you're only allowed to have 1 instance of each element. That's our basic rule from sets that we learned in primary school. So one way of creating a set is to use the set method, the set constructor on a list, but we can also just do a set comprehension. So let's say we have a database of books. So we've created a special object called book, and book has the following characteristics. It has an author, it has a title, and a genre, a type of book. And we've a list of instances, a collection of objects, book objects, and we have a couple of Terry Pratchett's, a couple of Ursula Le Guin's, a couple of whatever else is in our list or our collection of objects. If we want to create a set from that, let's say we want to just get the authors who write fiction, who write fantasy. We can see Terry Pratchett has 2 there. We can see Le Guin has 1, and we can see Turner has 1. So are we going to see Pratchett, Le Guin, Turner? If we created a list comprehension, that's what we get. Whereas with a set comprehension, if we said, give us the name of the author, that's the first element always, for all the books in the list, and let's check if the genre is fantasy. But the big difference here is instead of square brackets, we use curly braces. So because we're using curly braces, that means no duplicates are allowed. Therefore, our set will be the set Pratchett, Le Guin and Turner. So even though Pratchett should be there twice, if we had the square brackets, because we have the curlies, the braces, that means we only get Pratchett once because it's a set. And finally, let's look at the dictionary type. So we know in Python there's a special type of list called a dictionary. And a dictionary is a series of lists, but each list starts with a unique field or index to identify that list. So a label started off, that's a nice way of saying it. And as we said before, we could use a list method or a list generator to convert, a dictionary generator to convert a list, but we can also just use a dictionary comprehension. So if we take our set of books again, and we want to create a dictionary of that, and the dictionary would consist of the title of the book and then all the details about the book. So then if we wanted to look up a particular book and then find out all the information about it, instead of having to go into the book object and ask it book.title, we use the dictionary label to jump straight to a particular book. So our dictionary comprehension would look a lot like the set comprehension. It's curly braces again, except, and the first bit is different. The second bit is exactly the same. The third bit is exactly the same. But what we say is, this time, instead of saying b.author, we say, give us the title, colon, and then all the other details about that book. So we're saying that the title is the label, and then all the other information about it. So if I'm in the library and I type in the name of a book, it returns a record that includes all the information about that book. That's how the library lookup system works. It has all the information about the book associated with the title separately, so that the titles are quickly look-upable. You don't have to go into each of the book objects to query them. You just look at the labels, and then that label allows you access into all the details about a particular book. So it'll give us this, it'll give us the fantasy, all the fantasy books. It'll give us The Thief by Turner, it'll give us The Thief of Time by Pratchett. It'll give us A Wizard of Earthsea by Ursula Le Guin. It'll give us Night Watch by Pratchett. So then if we want to search all the titles that have the name Thief in it, we don't have to go into the book objects themselves, we just investigate the labels, which is a lot faster and a lot better way of doing things, a lot quicker for us. So we have a dictionary that can look up on the basis of title. So there you go, that's list comprehensions, set comprehensions, and dictionary comprehensions. Thanks very much. We'll see you on the next episode.